Hello, everyone, and thank you for joining us for today's webinar. This session is part of the Passive House and All Electric Homes Training and Workforce Development Initiative brought to you by the sponsors of MassSave. MassSave is a collaborative of Massachusetts electric and natural gas utilities and energy efficiency service providers, also known as the sponsors, helping residents, businesses, and communities of the Commonwealth save energy and money by improving the energy efficiency of our buildings. As part of this training initiative, the sponsors offer a 50% cost reimbursement for individuals pursuing professional accreditations for either Passive House or Energy Star. Once you have successfully completed your certification course, you can fill out the reimbursement application found on our website and submit it to us for incentive processing. The sponsors of MassSave also offer robust incentives to homeowners, builders, and developers who incorporate energy efficiency upgrades into their design and build high-performance all-electric homes. To qualify, single-family homes or buildings with 1 to 4 units must have heat pumps for space conditioning and electric appliances for water heating, cooking, and clothes drying. Homes can qualify for incentives through one of 3 eligible performance tiers, which include a base tier for homes that exceed the building code, as well as tiers for Energy Star, Next Gen, and Passive House certification. Incentives start at $7,500 a home and also feature innovative market transformation adders, which are designed to encourage participants to pursue additional national certifications for their homes and to incorporate emerging equipment technology to drive higher building performance and enhance occupant comfort. For multifamily buildings, the performance tiers and incentive structure is similar to that of single family, with the biggest difference being that multifamily buildings are allowed to have fossil fuel domestic hot water heating equipment while remaining eligible for incentives. Please note that the program defines low-rise buildings as having 3 stories or less, while high-rise buildings have 4 stories or more, or any multifamily building with centrally metered utilities for tenants. There are some slight differences in the per unit incentives for low-rise versus high-rise buildings, as you'll see in the chart on the screen. And lastly, there are some additional market transformation adders for multifamily buildings, including more options for heat pump water heating equipment, as well as incentives for whole building air infiltration testing. If you have any questions about these incentives, please do not hesitate to reach out to us at the email addresses shown on the slide. And with that, I will turn it over to today's speaker.
Thank you very much. Thanks for having me. I'm Steve from Steve & Winter Associates, and I am a HERS rater, Energy Star verifier, Lead for Homes verifier, registered architect, and I've got a lot of miles on my tires when it comes to air sealing. So that's why I'm speaking to you all today. Before we jump in, just give you a brief overview. So first of all, actually, could everyone, as I'm talking here, could you put in the chat box who you are? Not necessarily your name, but are you an architect, builder, developer, engineer, rater, building inspector? If you could just put in the chat in the next couple minutes here as I'm doing the intro, tell me what you are so I can tailor my presentation to hopefully make it good for everyone who's listening. Okay, so the Residential International Energy Code, Energy Star, LEED, Green Communities, all kinds of programs, certifications, standards use blower door testing to demonstrate air tightness of a building, residential buildings. Air sealing has often been left up to the trades, but increasingly with this tighter and tighter targets that we're being held to, we've really got to look at it from the very beginning. And so this would be pointed at you architects on the call. And so this session is aimed at air sealing in multifamily buildings, wood frame construction specifically. And we're going to try to explain how air sealing can do all kinds of good things for the building. Basically, like, why do we have to do this? Why does it matter? How does it work? And then we'll actually go through details, our suggestions based on years of doing this and thousands of units tested and certified. What we find to be the best way. It may not be the only way, but yeah, hopefully you get something out of it. So why do we air seal? If you're going to be required to do something, you better understand why you're doing it. So lots of reasons. Number one, to save energy. Building science gurus figured out a long time ago that air leakage equals energy loss, period. Every building is different, but as a general rule, you're going to reduce your energy loss and your energy costs by reducing air leakage. Pretty basic. Here's a really basic diagram of a multifamily building where we've got stack effect working on probably not a day like today where it's pretty warm, at least here in New York, but the colder the colder it gets, the more intense stack effect becomes. You've got air coming in. Let's see, where's my highlighter? You got air coming in the building down low, not much action in the middle. You got air going out up high. So the whole bubble here of the building, let's say your air barrier, your enclosure, the big bubble of the building is leaking everywhere. And the more holes there are, the more it's going to leak. But when you can isolate each apartment, make a bunch of little bubbles inside this bigger bubble, you're going to knock down the overall flow. So basically, the building isn't under as much stress from air leakage, which doesn't care about the stress, but it does care about the amount of air that's being lost out of the building and sucked into the building at the bottom. So adding up all the little bubbles that are tight contribute to the effectiveness of the big bubble. Here's an awesome picture that I love to show every time I can. This is from Dave Keefe up in Vermont. Building underway with the gut rehab. Look at how that plastic there, where they're gutting that facade, is sucking in the bottom, it's billowing out at the top, and it's just kind of flapping in the middle. I think that's just the coolest diagram of stack effect I've ever seen. I've been using it for like 15 years, 12 years now. Okay, so another reason, reduce moisture drive. So this is a classic south face diagram where on the left you've got a sheet of gypsum in, I think this is in a day, you can get a third of a quart of water by diffusion through this whole sheet of gypsum. If you had a 1-inch square hole in that sheet of gypsum, you're going to get 30 quarts of water. All right, so that's 100 times more water under the same conditions through a hole than through the entire 32 square feet sheet of drywall. So that's why air leakage makes a big deal as far as moisture drive goes. Sound and smell transfer, I think it's a simple rule that sound and smells also transmit easier through air than they do through solid materials, just like air, energy, moisture, pretty much most things that we care about as building science people. We've all been there, whether it's a hotel room above a karaoke lounge or a neighbor that's cooking some nasty fish. You really want to keep your bubble, your air separate from everybody else's there. How about that? So stopping flame and smoke spread, much like sounds and smells, fire and smoke can move easier from unit to unit, space to space through air than it can through a solid material. Super basic physics here. Here's just a couple diagrams. This stuff you're doing anyway for fire stopping, right? So we can also use a lot of this fire stopping for air sealing as well. Improved occupant comfort. Okay, here in New York at least, we have a lot of multifamily buildings with PTACs. It's an often overlooked location for air to leak in and out of the building. It's just a big dumb hole, honestly. And if thought isn't given to the equipment itself and how the equipment fits within the sleeve and how the sleeve is connected to the air barrier, it can create a real nasty draft in the wintertime. And so if anybody lives in an apartment with one of these, you probably get a cool breeze in the summer and the winter through your PTAC. So, and it's letting in smells, sounds, bugs, unconditioned air is just no good. I mean, they're fine, but you need to seal them up. That's what I'm saying. Stopping pest migration. I don't know, this one with the little ants creeping out. It's usually something a lot grosser than ants. But anyway, you don't want other people's choices to affect you inside your apartments, or your tenants, I guess, is who I should be directing this to. And obviously, compartmentalization, meeting the compartmentalization standards is going to be required depending on where you are and what you're doing. So 2021 IECC for multifamily buildings, FIAS, Energy Star, LEED, all these programs are going to require it. And so those, I'm sure everyone who's on the call, or most people on the call today, are familiar roughly, with the requirements. I'll have my contact information. I think at the end of this presentation, people are welcome to email me or call or whatever. I'm pretty easy to find. If you just need to bounce something off of us, you know, here at Stephen Winter Associates, we're pretty passionate and also pretty nerdy about this stuff. So we love helping people out when we can. Okay, how and where does air leakage occur? Okay, you're gonna have to bear with me because the first time I did this presentation years ago, it was around the time of Inflategate. So just no offense to you Patriots fans, and for the rest of you, I realize it may be a little bit outdated, so I maybe have to update this slide. But basically, air leakage requires two things. You need an opening, cracks, holes, or permeable materials, and you need driving force. That's the two things that you need to have air leakage occur, is an opening and a driving force. That's it. Driving force can come from wind, stack effect, and mechanicals. So theoretically, if one were to make a hole in a football and insert a needle in there, and then the driving force would be you squeezing it, that is how you would achieve air movement in this particular case. I gave this presentation the first time in Boston, and I got a lot of groans and a couple of dirty looks. I thought it was funny, but I don't know, not everybody did. But anyway, maybe it's time to retire this one. Okay, but that's what you need. You need a hole and you need driving force. Okay, so where does air leakage occur? Here's a cross section of building. Here's a floor plan of a unit. Air leakage is going to occur there, 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 and there. Pretty much everywhere you've got a connection between two assemblies or even two materials, that's a potential place for air leakage in an apartment. Okay, oops, next one. All right, so how can we control leakage and provide sufficient air sealing? I hope everyone knows what ambient versus adiabatic means. Ambient is outside air, adiabatic is what we use to describe an assembly that is between two conditioned spaces. So a demising wall, corridor wall, floors between two apartments, that's an adiabatic assembly. This diagram shows two identical dwelling units. One's detached, like your typical single family home, and the other is attached, as you'd see in a multifamily building. In the attached dwelling, only 16% of the envelope is exposed to ambient conditions, and the rest is adiabatic, whereas the entire envelope of the detached dwelling is exposed. So energy-wise, that makes a big deal, but compartmentalization-wise, as far as code and program compliance, that's been taken into account, right? So all compliance paths mentioned earlier specifically require blower door testing to be done on a unit by unit basis. Then that means air can be drawn in from every direction, whether it's from outside or whether it's from another conditioned space within the building. And so the takeaway here is that all air leakage matters when we're talking about compartmentalization. It may not matter as far as energy efficiency goes, but for the sake of today's conversation and for the sake of, LEED and Energy Star and whatnot, and for the reasons I discussed 3 minutes ago, all air leakage matters. Okay, so how do we control leakage? Here's one for you architects. If you can at all, minimize your enclosure area. So a perfect square is the most efficient way to enclose a space. I mean, the way we build things, of course, a sphere technically would be the most efficient way to enclose space. But anyway, deviation from that square will increase surface area in relation to volume. So there's a couple different metrics out there. There's the volume metric, which is ACH50, and then there's the enclosure area metric, which is CFM50 per square foot of enclosure area. So again, these two, shapes, apartments, whatever you want to call them, have equal volume and floor area. This one down below has 9% more enclosure area just because of its shape. It's longer and skinnier. It's less efficiently shaped. 9%. If I can magically give my construction teams a 9% bonus on their compartmentalization test targets, like I would be their hero. Because a lot of times, depending on who you're working with, it comes down to, a few CFMs. I mean, 9–10%, that would be a lot of wiggle room that I know a lot of teams would really appreciate. So it may seem like an obvious dumb thing, but it does matter. So also in regard to simplifying the enclosure area, simpler shapes are going to be a lot easier. So remember, we said air leakage is going to potentially occur anytime we have an assembly, two assemblies or two different materials connect, or multiple assemblies or materials. So look at this diagram from this multifamily building. You've got this unit up here and you've got this unit down there. Which one of these is going to be easier to air seal? It's pretty obvious. You got 4 corners down here in this rectangular shaped unit. You've got 18 corners up here in this one. I would have to imagine the surface area of this one is a lot larger too. But basically, this designer made it much harder to get this apartment sealed up than this apartment. Okay, so knowing priorities. So we talked earlier in the stack effect diagram about the big bubble and the little bubbles. Big bubble is the whole building enclosure, and the little bubbles are each apartment. They work together, but when you are designing for compartmentalization and building to meet compartmentalization requirements, you've got to understand which one to address first, and that is the big bubble. Hitting that exterior envelope first, getting it sealed up should always be your first priority. It also comes first in the natural sequencing of a project, unless you're doing modular, which is kind of an odd duck, and sometimes works better for compartmentalization and sometimes doesn't. We can get into that later with the Q&A if you want. But anyway, getting that big bubble defined, built, and verified is your first priority. And then you want to focus on what usually the little bubble is your drywall perimeter of the apartment and your floor and your ceiling. And just keep in mind the verification methods are visual. As far as you know, Energy Star and HERS raters out there, we do a visual verification of air sealing at the building-wide level. We do performance testing, blower door test, on the apartment level for final completion verification. Okay. Oops, I didn't have an animation there. Sorry. Yeah. All right. Anyway, I'm left here not selling any products, but this one in particular, it has solved quite a bit of problems we've had in the past with the big bubble, the exterior envelope of the building, just because of sequencing. This approach has minimized the opportunities for details falling through the cracks, for mistakes on site in implementation. So I'm kind of a big fan there. And then, sorry, this other approach theoretically can work if these, roll-on materials, not rolled-on, I should say, sheet materials are actually installed according to the manufacturer's instructions for an air barrier. And again, this is your big bubble. You're never going to see this on the inside of the building. It can be done. I'm not as big a fan as the newer approaches. Here's on the right-hand side here is also a similar sheet material, slightly different. This one I do see used inside buildings, more so on passive house projects where they've got a higher threshold to meet for moisture control, pushing the envelope a little harder than the rest of us just building to Energy Code and Energy Star. But they get really aggressive about sealing all these connections, whereas out here, there's plenty of tradesmen out there that just will slap it up, not care about how the bottom's connected, how the top's connected, penetrations, seams, everything. So, but anyway, the one thing to keep in mind here is that there is no, the air barrier is not a material. It is typically going to be a group of materials working together. So you see up here in this draft stopping detail, we've got the floor sheething is probably part of our air barrier. This drywall blocking here is part of our air barrier. This caulk, the connection is part of it. The fire stopping is part of it. Even the top or the last piece of this wood truss is part of the air barrier. The top plate is part of the air barrier. So it's, you're not going to say, oh yeah, we're going to use some fancy vapor retarder, air barrier, and all our problems are solved. That's not how it works. It's a kit of parts that needs to work together. Okay. And by the way, you guys, Keenan and Anna, you'll let me know if someone raises their hand with a question, right? Because I cannot see it if someone does.
Yes, we'll let you know.
Awesome, thanks. Everybody's probably still mowing down on their lunches. Okay, so how to control leakage? We need to seal the perimeter of every unit. That is our go-to approach. And if done correctly, it works every time. There's no reason it shouldn't work. So anyway, after we have defined the exterior air barrier on the outside of the building, we're switching gears a little bit, and here we go. So now we've defined, at least in 2 dimensions here, the enclosure of our apartment. This is the air barrier, graphically at least. So, like I said before, you're gonna have air leakage, not in one big sheet of drywall. There's no air coming through that. You're gonna have a leak where there's a hole through the drywall, where the drywall stops because it hits a door, where the one piece of drywall hits another piece of drywall and other framing. That's where leaks happen, right? So I started the corners, and basically what we're doing is trying to isolate each assembly from the next assembly. So if you look at this corner here, this isn't the perfect detail, but basically we're sealing the drywall to that first stud to prevent air that's in the demising wall volume cavity from getting into, from the corridor wall from getting into the demising wall. And so we've got a wire here that's coming through this last stud. We're fire stopping that. That should be in everybody's scope of work for a multifamily building. The trick is when you install the drywall, or when you specify the drywall, how it's supposed to be installed, the one piece needs to go on, get sealed to the framing, and then the other piece can go on, and then it gets mud and tape. The mud and tape don't do anything for keeping air movement from occurring from one cavity to the next. You've got to seal at least one of the pieces of drywall to the framing, and then when you seal the other piece of drywall to the first piece of drywall, that's the last piece of the connection. So this is super huge. This connection between drywall and framing, that's what achieves our air sealing. It's not drywall to drywall. Well, it is, but that's only secondarily. It's a framing to drywall, framing to drywall, framing to drywall. Did I say that enough times? Okay, so if we can do that at the perimeter corners, now we're going to do it every time the perimeter intersects an interior partition. And so in this apartment, this is actually pretty minimal. There's one here, 2, 3, 4, and maybe something funky happening behind the tub, 5, and 6. Actually, and there's a little bit of jog there. That might actually be 1, 2. So 6 or 7 opportunities again for air from, let's say, the demising wall to sneak into the interior partitions. Because if we want to keep our air barrier at this perimeter, that saves us from having to air seal everything inside the apartment. There's many more penetrations and edges and seams and holes inside the apartment than there is at the perimeter of the apartment. So that's why we put our first line of defense at the perimeter, and that way, if we do a good job out there, we don't have to really worry about any sealing inside the apartment whatsoever. Okay, so this is a concept that we have gained a lot of traction with, especially with construction teams. You just got to imagine taking each apartment in the building, magically yank it out of the building, and dunk it underwater. Most people, can visualize every time you've got a connection that's not completely sealed with caulk or foam or something sticky, water will press through there and will get through. Air will move between wood and sheetrock. On paper, what architects like, no, that's tight, right? No, in real life, it's not. It'll leak. So try that approach as architects you're designing, contractors you're building, raters, you're leading others in training them how to do this. It's pretty effective for us. So air will go wherever it wants as long as there's a way to get in. So will water. So moving on, so back to the perimeter. In addition to these connections, which basically are, this is where drywall stops, right? There's a sheet of drywall or two from here to here. It stops when it hits this first stud of interior partition, then it keeps going. So again, it's an interruption in the drywall. While other interruptions in the drywall include plumbing fixtures, electrical outlets, hood, duct vents. Basically, there's also other holes in the perimeter drywall of this apartment. So that's where these little details come into play. Access panels, plumbing penetrations, electrical boxes. Here's your P-tax next to your wall. Millwork, again, that piece of sheetrock, it's nice and tight way out here in the middle of a piece of sheetrock, but what happens when that sheetrock stops at the door opening, right? This one's an easy one to solve. You just typically, in most scopes of work, you're already caulking the trim to the drywall and it's painted, right? So there's really no additional work that needs to happen here as long as that trim is also caulked and painted to the jamb, and the jamb has gaskets around it that seal to the door, and then the door has a sweep on it that seals to the floor. Which, by the way, if you're not doing that at your multifamily dwelling entrances, from the corridor or whatever, you're not meeting fire code, FYI. Here, duct takeoff, same deal. So if we can seal all these interruptions in the drywall, the perimeter of our unit, then we're good to go. No more questions. Gosh, they're quiet. Okay.
Hey, Steve, there's one question.
Yeah.
Do you have any examples of types of sealants or preferred sealants for the sheetrock to the framing assembly?
Yes. I will actually, you know what? That's in this slide. Good question. Good timing.
Perfect timing.
All right. So architects, the big thing for you is to choose and most importantly, develop details, specifications specific to each project. So you are welcome to use our air sealing guide, which has been online for years and years, and it's been used many times. Architects have a tendency to just snag it, snapshots off the PDF, paste it right in their drawings, go for it if you want, but you're going to have more success from actually taking your own details and updating them to include air sealing tasks. And again, it's typically just that bead of sealant, right? Because our air sealing guide is very generic. It's meant to be used as a guide, and that's just it. It's not an actual scope of work. We are actually working on a scope of work for different construction types. That's item 472 on my to-do list, but that's coming. But as of right now, our air sealing guide is just like, hey, here's a kit of tools that you can use. It's up to you to actually get them into the design. Going back to what we were talking about as far as adiabatic versus ambient leakage, it really doesn't matter. You've got to do your testing unit by unit, and it cannot be guarded. Guarded means multiple blower doors running at once. You got to have just testing one unit at a time. And for the programs I typically support, you cannot do whole building testing. You may be able to for energy code, although I don't really know that anybody does. Typically, most programs, you're going to have a maximum of 0.3 CFM 50 per square foot enclosure area. It may be different elsewhere. I don't actually know where it would be different. I can't think of anything right now. LEED requires 0.23 if your average apartment floor area is greater than 1,200 square feet. But otherwise, 0.3 is typically what you're going to be designing to, and you need to hold the contractor to that. So this is actually a performance specification, and it's literally just a line on the drawings or specs that says you must achieve, contractor, you must achieve this level of compartmentalization. And they can, sorry GCs, but you can scream and kick all you want down the road, but if you bought that scope of work that says 0.3 CFM 50 per square foot enclosure, you got to get there, whether or not the architect gave you the details. I don't want to get into the weeds. I usually, when that starts happening, I kind of keep my head down and let them sort of bat at each other, stay out of the crossfire. Be specific. So here we go. If you've got a gap that's 1/4 inch or less, you can use caulk, sealant, whatever. If you have a gap that's 1/4 inch or more, try to use something that expands like foam. There's also really cool tape out now. What is it called? Anyway, that we're using at window rough openings. You put the tape down and it expands and pushes really tight against the window frame. Pretty sweet. Also relatively expensive, but works really well, I guess. But anyway, because your caulk is going to shrink and crack and fail if you're applying it a greater than 1/4 inch of width. And use your appropriate sealants. So I don't have a brand, I don't have a particular kind that I'd recommend, but just, you know, low VOCs ideally, especially if you're pursuing a green certification. High temp if you've got hot pipes and whatnot coming through. Low expanding foam is good around window roof openings, so it doesn't get in the way of the window operating. Fire rated, you know, depending on your building official, they may get real fussy about what sealants you use in a fire rated wall, right? And then here's one for you contractors and even architects, feel free to put it in your specs, why not? You can't just slap a bunch of sealant down and expect it to stick. Yeah, it's gonna stick, but it's gonna stick to the 16th inch of drywall dust that's on the floor, and it's not gonna do squat as far as air sealing goes. Or it may hold for a little while and, you know, just no time down the road it's gonna let loose and you really didn't achieve anything. So clean out them holes and prepare them properly before you actually seal them. Like I said, there's some new products out there, all kinds of tapes. Man, tape is just, when I was in architecture school, our professors would say, we build a model and they'd say, well, how's it supposed to stand up? You can't use it with glue and tape. And then, of course, it's 2023 and buildings are basically built out of glue and tape as far as their barriers go. Whatever. Okay. You know what it really comes down to is owning it. I don't want to sound like a big crybaby, but I understand that the energy code in the hierarchy of, you know, fire and safety and mechanical, electrical, plumbing, all that stuff, accessibility, etc. Energy code and the sustainability stuff is probably toward the bottom of everybody's priority list. I get that every day. It's fine, but it doesn't matter that you don't have, or it doesn't mean that you don't have to do it. If you're doing code or any of these programs that require compartmentalization testing, it's got to get done, and it's going to be a lot less painful for you to do it proactively than to try to scramble at the end when you're getting people moved into the building and we haven't completed our blower door tests yet, and we roll in there and find out that a bunch of air sealing wasn't done, and now you've got guys coming in, and I've seen, you know, spray foam up in some ceiling dropping on a nice lady's sweaters in her closet because the builder just didn't take it seriously, and we're like, well, you're not passing, so we're gonna have to figure it out. So look at the body language of all these guys. This is classic. It's not me. Was it me? Was it me? Was it me? Was it me? Architects, you got to get it on paper. Builders, you gotta, I would say, put one person in charge. Have one person on your crew, if you can afford it, be, you know, responsible among their other responsibilities, but be responsible for air sealing. And they've got to check the subs work, and they've got to recheck the subs work, and then before you enclose those walls or move on to the next phase, triple check that the work is done. If you bought it, you should get it out of your subs. Otherwise, it's going to be your headache later. Raters, consultants, yeah, reach out to us if you want us to, for example, tag along with the trades training, which is something we do on every project. We get out there with the GC, the subs, and maybe even the architects, maybe even the owner, and we look at each other square in the eye and say, do you own that? Do you own that? Do you own that? Do you own that? And we work it all out right there. If somebody didn't, if nobody bought it, then the GC's got to figure out how it's going to get done. Yeah, you got to own it. I've had buildings with one half, they finished before the other half. First half, they didn't take it seriously. We struggled. We ended up having to fix and test every single apartment, you know, 50, 100 some units in that half of the building. After they learned the hard way, the second half of the building didn't have any trouble at all. We passed them all the first try. We sampled, painless. Nobody lost any sleep through any fits. So done does not equal done well. And that's especially true for air sealing. Okay, any more questions pop up?
Yeah, Steve, couple questions here. Because for corner seams, because mud and tape is not sufficient, how would you air seal the horizontal seams of drywall or where two pieces meet vertically mid-wall and are mud and taped?
All right, let's go back. Okay, is that the only question?
There's one other, but
okay.
We'll
I'm thinking actually we will get to that. So what we're going to do now is you guys just got the, you know, the why You got the basics of how best practices. Now we're going to get into a unit and run through it in 3 dimensions and identify how to do it. So I will keep that question in mind as we move forward. What's the second question?
Second question is regarding big bubble air barrier. With the zip style sheathing control layer, do you go beyond the manufacturer spec for recommended detailing and recommend to seal it to the plates and framing?
We will also get into that, but the quick answer will be, it all depends on what you're trying to achieve. If you're doing the big bubble, the exterior air barrier, if that's what you're worried about, if you install it to manufacturer's instructions, I don't see any reason to go beyond that. What may be lost in translation is connecting. So the window opening, we know how to seal that. A penetration, we know how to seal that. But what about what happens at the bottom of the wall where that zip sheathing stops and now you've got concrete or wherever your foundation is? Do we have that sealed? Conversely or inversely, at the top of the building, where the zip sheathing stops at the top plate of, let's say, your roof heel, what's happening there? So, but the basic answer to the question is, we are perfectly happy with the way that system has been designed, and that's how you're supposed to do it, basically, is what I'm trying to say. But again, we will, in this design exercise, we'll get into the specifics to make sure you don't miss anything.
One more quick one. Is the compartmentalization testing requirement for Energy Star, is it 0.15 CFM per square foot of shell?
No, it's 0.30.
0.30, got it.
0.15 is, I believe, the enhanced compartmentalization and lead for homes that gives you credit.
Great, okay. That's it for now.
Great, all right, I'll try to get better at answering questions, sorry. Okay, so here we go. Here's your basic apartment. Demising wall, exterior wall, demising wall, corridor wall. I don't see hands raised, so I'm not going to ask. Usually I have to ask, okay, who can tell me where we want to start? Well, we want to start out here at the exterior wall. So again, we've got, maybe I can draw it. We've got our exterior air barrier out here, outside of the wall. Oh, it looks like this one splits a window. That's kind of weird. Didn't notice that before. In this case, let's say, for example, if we had zip sheathing, we've got tape at the window openings. Oops. We've got tape in the corner. We've got tape at this corner. We've got tape at this window opening. We've got tape in this window opening. And keep in mind, we're looking in 2D here. We've got tape here. We've got tape here. And on it goes. So really, I'm not worried so much about air leaking from outside to inside here. I mean, obviously we have penetrations, we've got the windows, etc. But through the zip sheathing itself, I don't expect any air leak through there. There's no reason it should. Oh, by the way, with the zip, you gotta use the rollers. The tape will not bond with the green substrate if there's not enough pressure placed on it. So I guess that's one thing that is in the installation instructions, but often gets overlooked in my opinion. They just slap the tape up there with their hands and that's good enough. No, it's not good enough. You got to use a roller. So anyway, okay. So we're good there for the big bubble. Thank you. Okay. Let's look at it in the other direction. Okay, so here's the section detail. Again, we've got our slab down here, we've got a bottom plate, we've got some sill seal underneath, which, by the way, is only a capillary break. It is not an air seal. It is just meant to stop water that's in the concrete from wicking up into the wood. You still need to seal it. So in this case, in our detail, we seal it up here, which prevents air from leaking in from the outside into that wall cavity. And by the way, this doesn't just hurt the whole building air leakage, it also hurts the effectiveness of this insulation. That's why it's been on Energy Star's closure checklist for Never, 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 never. Okay, so now we've got the drywall stops right about here. We don't have any gypcrete here. We just got finished floor on concrete. And usually this is a pretty big gap. So that's why this detail shows 2 beads of sealant. But basically you want to connect the drywall to the plate to the slab. So that way, this air that does leak into this wall cavity cannot come through there, right? So now we've effectively stopped air movement both into the wall and through the wall. Any questions about that? Okay, cool.
None at the moment.
Architects, look how this slab edge is protected entirely with rigid insulation. By the way, that's been required since the beginning of time. That's in another presentation of mine. Okay, let's move up to where the first floor stops and the second floor begins. Whole lot of stuff going on in this detail. And by the way, these details are straight from our air sealing guide. Okay, so let's keep looking at this exterior air barrier, right? If we've got, let's say this is a product again, there's really nothing penetrating this except this duct. So if they've got tape there and tape there, our exterior air barrier is good. So to answer the first question from a few minutes ago, if you're only worried about the big bubble, you don't need any of this other air sealing in here. All this additional air sealing in here is doing is stopping air movement from one unit to this cavity to another unit. I'll stop for a second there so that soaks in. So the only of all these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sealant icons or whatever you want to call them, in this detail, the only 2 that are needed for the big bubble is this one and this one. Okay, but we're talking about compartmentalization. So we have to ask the question, is this volume of air in here included in any apartment's infiltration volume? Is it included in this apartment's infiltration? Is it included in this apartment's infiltration? Typically speaking, and most of the times in wood frame construction, it is, how do I undo marks? Erase all ink on slide. Oh, that works good. Okay. Actually, I'll go back to my laser pointer. Okay, typically this volume of air will be included in the apartment below as far as infiltration goes, compartmentalization. That's not always the case, but let's start there. So that would mean this is our priority up here. So if we decided that, actually I will go back to drawing, tight. So we decided that the top of our air barrier is here. The exterior air barrier is here. And then we don't really care then about this sealant down here because this air and this air down below are all part of the same apartment. This will be included in our testing target. But if you don't do something up here, you can very easily get air leaking into the wall, and then it'll sneak back here into this cavity. And once it sneaks into this cavity, then and if we're not doing anything here, it's gonna go whoop, right into this cavity. Now you may ask, I'm drawing straight through this drywall, right? Well, yeah, no air is coming through the drywall right here, but if you had an electrical box that wasn't sealed, then you would have air through there. Or if you got a electrical box here for a light fixture, guess what? It's going through there. So let me erase all my scratches again. All right, so anyway, so this is up here is what we care about for compartmentalization if the volume of air in the floor cavity is included in the unit below. So right here, this one seals air that may sneak behind a plate, behind the sheathing in a typical platform frame construction, behind this framing too, and into here. It'll do it. Doesn't look like it on paper, but trust me, it happens. Okay, and then again, we have a similar detail here where we've got the drywall sealed to the floor somehow. And so again, that'll stop if there's any air from here coming up through here, it'll stop it from being able to access into the apartment. Now this is gypcrete is what this is meant to indicate. Most of the time, your gypcrete is going to be sufficient to stop any air leakage from here into here and vice versa. But not always. If it's not installed correctly, if the drywall guys got a little too loose and wild with the drywall and it's up too high and the gypcrete doesn't touch it, then you don't have a seal there. So and also there's the isolation, what is it called? The isolation strip, that little foam gasket they usually put in there. The best approach is to cut that off and then give me a nice seal here between your drywall and the gypcrete, and that's golden. Architects, you may have this detail already in your drawings for acoustic purposes. So, you know, you're already paying for it. It's already in the design. It shouldn't be anything new. It's just that someone needs to actually check it and verify that it's done, which doesn't always happen for little stuff like that. And just think, in a building, you could have thousands and thousands and thousands of linear feet of sealant. So, you know, GCs, if your subs aren't saying, oh, well, this includes, you know, X dollars for air sealing, you better ask them for it if it's not obvious in the drawings, because you're going to end up paying for it eventually when you start doing load tests. Okay, now if this volume of air up here was excluded from the apartment below, then we would want to, again, we're sealing drywall to the framing. Here's our tape and mud. That's not doing a whole lot for us. In fact, you know, that drywall down here could even not exist if we're really being abstract about it. But anyway, you're sealing between the drywall and the top plate, you're sealing any penetrations through the top plate, and then you're sealing the backside of the top plate to stop any air from sneaking behind that framing, behind the sheathing. Who's lost? Keenan, any questions?
Couple questions here. The sealant dots are shown in the nook between sheetrock and framing. Could it instead be sandwiched between framing and the sheet?
Yeah. Oh, yeah. Diagrammatically, yeah. Typically, what happens is this sheetrock is held back, you know, quarter inch or so, and then they just caulk it from below like this. Does that answer the question?
We will see. And then how would you horizontally air seal the bottom plate where the vertical stud is in the way?
You don't. So what that question is, so if you got in 3 dimensions here, so bottom plate, stud, we've got, let me change colors. You've got sealant here, oops, here between the plate and the sheathing. You got sealant here between the plate and the sheathing. You got sealant here between the plate and the slab or the subfloor. You don't have anything here and on the other side in there. And basically we just eat that loss. We've decided that the 1.5 inches behind this stud where it touches the sheathing, you're not going to get it perfect. You got to aim for the stars, land on the moon, something like that. If you want to get to passive house levels, so the passive house folks are really good at getting these things worked out at the big bubble. You can try to apply it to the little bubble, but I don't know that you're going to get the benefits out of it. That it's gonna be a net loss as far as cost and time goes, versus, you know, improving indoor air quality and compartmentalization results.
What challenge do resilient channels or sound clips that keep the rock off of the framing for sound present?
Good question. Okay, so let's say this is the bottom. Oops, this is the bottom of my truss. And somebody didn't draw the truss cords in there. That would be me, by the way. And let's say we've got our C right here, and then we still have our drywall underneath. Doesn't matter. Seal the drywall to the plate, and then make sure the plate is sealed to the sheathing somehow. So if they're sealing way down here instead of at this connection right here, the best practice is to seal the seam between the double top plates, seal the second top plate to the drywall, and then also obviously seal back here, and then seal any penetrations through. So that's how you do that.
And then last for now, you've mentioned a few times a air sealing guide. Is that publicly available, or is there a link that we could share with everyone?
At the end of the presentation, there's a link.
Great.
Yeah, absolutely. And we've got one for wood frame construction, steel, and masonry. We're in the process of updating. We've updated wood, although it needs more updates. Steel and masonry are lagging behind a little bit. The concepts are all the same. Like I said, we nerd out on these things and we like it to be perfect. Unfortunately, it's just too far back on my priority list. I can't guarantee when it's going to happen, that those get updated. But yes, they're definitely publicly available, and I will provide a link at the end for it. And it'll be in the presentation, obviously, also. I'm assuming it will get distributed, or maybe not, slides. Okay, should I move on?
One question just came in here before we move on. Anything we should watch out for if considering sealing drywall as the compartmentalization boundary? I'm consulting for a multifamily project that's historic building renovation, and all the drywall is being replaced, but the old floors are staying in place.
Awesome. Totally doable. I will cover that in a minute.
Great. Then we're good for now.
Okay, cool. All right, so here's the top of the wall. This one just happens to have an attic and a pitched roof. So going back to the question about the zip sheathing and the instructions and whatnot. So here you go. You've got to seal the top of that zip, which is, that's where the air barrier ends. You've got to connect it to, so this is your vertical air barrier. You got to connect it to your horizontal air barrier, which is what in this case? Well, it's the drywall, right? All the way underneath that unconditioned attic. And it's the top plate of the wall. So again, your air barrier is not one material. It's your zip on the outside. It's your sealant right here. It's your top plate right here. It's more sealant right here. And then it continues on as the drywall right there. And by the way, once you get to an electrical box for a light fixture, you better seal that up too. So, and now that electrical box is part of your air barrier and the sealant that you use to tighten it up. Yeah, so again, two parts. And again, you're sealing right here so you don't have air leaking from the attic in your wall and ruining your installation and performance, and also getting into the apartment somehow. This is actually pretty easy, but man, is it also easy to miss, especially this, because the framers get all excited and maybe it's in their scope to put in these ventilation baffles, and they get them in, and then they've got to soften up. Oh, the building's watertight, super important. I get it, but you missed this connection. So now you've got to dig, you got to crawl in there on your hands and knees and get to this and seal that up, because you're surely not taking all your soffit out. This is easy enough to hit by the drywall crew inside before the wall insulation is installed, and which in my experience is typically the way it works. The ceiling goes in first. That's number one, and the walls go in second, number two. Questions? And by the way, these are, go ahead.
When you use panelized exterior walls, does the approach to the ceiling change?
It can. So in Energy Star, they got pretty specific about not relying on framing adhesive for air sealing. So theoretically, let me go back a slide. So theoretically, let's say, oh geez, I gotta delete all my scratches here. Panel 1 stops here. Panel 2 starts here, and then you've got your floor structure. Yeah, sometimes they will put adhesive. Maybe all the times. I don't actually do a lot of panelized projects, so I'm not sure, but I'm pretty sure they'll put adhesive between the framing and the sheathing on your panels. In concept, that may work. And you may rely on it for compartmentalization air sealing, but Energy Star doesn't buy it, because what happens a lot, Energy Star doesn't buy it at the exterior conditions like this, because I mean, they're putting that stuff on at 100 miles an hour. There's, the caulk gun farts, right? And like an air bubble comes out and they don't care. They just keep going. Not that people are trying to do a bad job, but everybody's moving fast. It's hectic. It's crazy in the factory or in the field. You can have a lot of missing spots where air is going to leak through. So I think that's why they don't allow it. Sub question, how does drywall adhesive work? Well, same deal. It can work theoretically. It's just impossible to verify. Once the drywall gets stuck to the studs and the plates, I mean, how do you know how consistent it is? And again, those guys go 1,000 miles an hour. Because we are verifiers, we prefer details that actually can be verified that they're done correctly. So yeah, I don't suggest that, but it definitely has been used and used successfully. It all depends on exactly, going back to before, done is not the same as done well, right? More question? No.
Good for right now.
Okay, good for now. All right, so now to go back, once we have, let's say we have sealed our exterior wall nice and tight. Now we're going to focus on our demising walls, corridor walls, and interior partitions. Can anybody, I can't hear you, so I'm not going to ask, but I'm just going to go around and count all the connections here between, all the connections that we're going to have to worry about at our, let's see, our adiabatic assemblies. We got 1, 2, 3, 4, 5, potentially 6 underneath that tub, 7, HVAC closet, 8, 9, 10, 11, 12, 13. There's that little wall underneath the island here, the peninsula, I guess, technically. 13, 14. Okay, so now that is 14 just straight up drywall connections. That says nothing about electrical box, pipe penetration to the sink, electrical box, kitchen hood exhaust out, electrical box, light switches. All kinds of, oh God, all kinds of penetrations in an air handler closet. Lordy. Plumbing penetration. Plumbing penetrations, valves of this tub. Plumbing penetrations. Again, a laundry access box, which is a big fat hole. This is probably a tankless water heater, so that's got both piping and flue connections out. Electrical box. There's probably no one in the closet. But anyway, okay, you get the gist, right? There's a lot of places where air is going to come through that perimeter of ours. So here's the same detail I showed before. Again, it is the sealing of the drywall, first layer of drywall, which is typically at the perimeter before they do interior partitions. That gets sealed to the stud. This has been fire stopped already. And once this is tight, then they can install this piece. And obviously no air is going to leak through that corner because you got tape and mud. So there's where the tape and mud come in. It's just literally connecting the one piece of drywall to the next. But the first step is here before the drywall comes in. And now, so again, this is at corners and at interior partition intersections. Oh, I missed it. There's one here too. Okay, so here's one that I'm just going to take out of our air shielding guide. This is actually a better way to do that detail, and the light gauge metal guys do this anyway, where they will leave, I think it's called a slap stud, or it's also, I learned a new name for it. Dang. Anyway, they keep this last stud loose, and so that they can run the drywall past and get it screwed to the studs in here, and then they slap this stud up against that drywall there, and then they rock it. And so again, the tape and mud are there and there. Ideally, the trickiest part is actually to seal the penetrations in both the drywall. You don't have to seal in the drywall, but it's tough to do when the slab stud's in the way. This is definitely a way to do it, but in wood frame construction, for whatever reason, I don't think there's any reason architecturally or fire rating wise you can't do it. It's actually better, but the wood framers, they just don't think that way. They got to have wood touch wood, and they got to slap the heck out of it with nails. And I don't know that I've ever had any luck convincing a framer to do it this way, but it is better for what it's worth. Okay, so, and you got to look out for, I've been showing you this nice rectangular apartment, right? Easy peas. You can really start getting into some crazy stuff. So here's what I call a flyby wall, where, so here's the demising wall between one apartment and the next. And like any good architect, these guys extended this interior partition to line up with that living room wall. Makes total sense. But you got an opportunity there for air leakage because you won't typically have any air sealing right there. So you're gonna have this piece of drywall go on, this drywall. Well, you don't have anything stopping the air that's in here and in this cavity from leaking into this interior partition and then out through, all the pipes that are connected to this air handler or dryer or whatever the heck it is. So this is what I call flyby. You also need to look out for chases, double walls, dead spaces, underneath tubs. Like drywall, if drywall stops at the tub lip, what about the 30 inches between the tub lip and the floor? Wide open for air leakage. Also for fire. I mean, they should have rock down to the floor for fire, but I doubt it's getting sealed to the floor, right? Okay, and again, we got to think of 3D. Typically, we will draw the line here. So there's gypcrete up there, there's gypcrete down to the bottom, and then we've got drywall in between. That's typically how we do it. But I have seen more and more builders have success, for whatever reason, drawing that line here instead. And the main difference is, in this approach, obviously you're sealing this connection, this connection, this connection, and you're sealing this connection now. Remember before when I said, yeah, you got to seal here for sure if this space is included in down below. But if it's not, you've got to seal here as well. You've got to seal both above and below, because this volume of air doesn't belong to any apartment now, because the shape of this air barrier goes up like this, right? So this is no man's land. You've got to seal here where these top plates or tracks hit the drywall there. And that's, to stop the air that's in this cavity from sneaking into this interior partition and then out into the apartment somehow. That makes sense? Should I stop there for a second? Yeah, I'll show you detail what that looks like. So here at a double wall, you just basically need to put a piece of framing there. I haven't had any trouble with fire inspectors rejecting that. Or you can use just like spray foam or something in between these top plates. So that stops the air from up here from leaking down into that cavity. And then again, if you've got your sheetrock to wood there, you've got your sheetrock to wood there, you got your fire stopping and penetrations, you're good to go. You're not going to get any air down here from up there. And what does that look like? Well, here you go. Here's some pictures. So this is typically what it looks like, right? They rock the ceiling first, they stop. So any GCs that are out there, this is a sequence thing. Do the ceiling first, and they've got to stop, seal that connection, and then they can do, let's say, exterior walls, stop, seal this connection, and then do the interior partitions, right? Actually do the demising wall first, stop, do the interior partition connection, and then do the interior partitions. So it's all about sequencing, right? It's also very important, like in this case where you got all these penetrations, and sometimes I've seen they just plain cut the top plate out because they've got so much stuff going through there, big pipes or whatever. The fire stopping is really important, especially in these cases. And then don't forget inside of chases. That chase is inside the bubble inside the footprint of your apartment. We got to make sure we hit the top of that too. Either way, you're hitting the sides of it, right? Because, and this is what we call pre-rock. This will be done long before you start doing any of this, actual drywall that you see. And again, a lot of times this is required for fire code anyway for rated assemblies. So But typically, again, we have draft stopping, which is this stuff, stops air movement, well, stops fire and smoke from one space to the next, but we can also use it to stop air. So here's just showing this unit's air barrier there, and this unit's air barrier here. We've got caulk, we've got sealant, everything's connected. Connect the dots. Here's a unit side, corridor side. These are typically framed differently. Same deal. You've got, actually, no, this is drawn backwards. This, oh yeah, no, that's right. Goes on the unit side. So there's the air barrier for this unit. We don't care what's happening out in the corridor. Doesn't matter to us. Doesn't affect the test. They have gaping holes there, or drop. Actually, a lot of time they have acoustic ceiling tile, which is not an air barrier. Here's what it looks like from the other direction. Here's what it looks like in real life. I don't know why in this picture they've got drywall and they've got OSB for the draft stopping. That's not my picture. I gotta ask my colleague why they did that. But either way, you get the intent. You don't stop air movement from cavity to cavity. And again, hitting all those other holes in the drywall. Okay, I've got time for more questions. It's 10 after. I've got one more section on townhouses, if you all are still with me, but I'm willing to take a time out and answer more questions.
Yeah, one unanswered question, Steve. So ideally, each sub is responsible for sealing their components of the air barrier, and the general contractor does QC. But when does it make sense for a dedicated air sealing contractor to get involved, or the magic foam mist? In other words, do you have a preference for how the air barrier is scoped out based on your experience?
Yeah, good question. I've often wondered myself if it would be profitable to get into the strictly air sealing business. Most of the time, air sealing is going to be done by an installation contractor or a specialist like Aero Barrier is the magic mist that was being referred to. Aero Seal started in ductwork. It worked so well in ducts that someone said, hey, let's do it to a whole apartment or to a whole house. And it does work. It works magically. It will save your subs money on air sealing their stuff. They still have to fire stop, but I am seeing it used more and more on multifamily projects because, again, these guys are moving so fast. The energy stuff is toward the bottom of the priority list. They don't want to think about it. Their brains are full with other stuff, and so they just kind of throw money at it. And but it's money well spent, I think. But as far as who owns it, yeah, typically GCs will cover it. I don't know if there are actually air sealing contractors out there that only do that. I think the reason why is because, and the reason I probably won't ever get into it, is because there's just too gosh darn many variables. Again, it's sort of a pecking order, right? I could foresee the air sealing crew just getting kicked around by everybody else. Everybody else making holes after the air sealing crew has been through. I mean, really what you would need is like one person there all the time, every day, just like constantly making loops around the building or whatever floor is getting worked on at one time, and just hitting what they see and then start at the other end of the building, hit what they see, start at the other end of the building. It just constantly, it basically would work just like Aero Barrier works, where it's constantly just finding holes and slowly sealing them up until boom, you get to where you want to be. Yeah, I don't know. Otherwise, I think it's just the GC has to put somebody in charge of riding herd on the subs. That's typically the way it works. And some do it better than others. Some people, right, they don't lose any sleep over it. They've accepted they got to do it. They push hard on getting it done right, and then they can worry about other stuff. They don't sit there wondering, oh crap, did we air seal enough? Are we gonna have to get charged a bunch extra to do a bunch of extra work? So I got to come back 3 times at however many dollars an hour, blah blah blah. So.
One other question, do you find it's beneficial to extend the drywall up to the underside of the sheathing at the exterior wall? It's an additional cost, but is the benefit worth it?
I actually haven't ever seen it done for air sealing purposes. I think I've seen it done for certain construction types, or that's just the way the architects draw, to bring the interior drywall in each apartment up to the underside of the floor above. I think it's great if you want to do it. Does it pay? I don't know. I think it's obvious if it's required by your construction type. Yeah, definitely use it because it'll make it easier. I also think for whatever reason, it's easier to seal against drywall than to just framing to framing, right? Drywall to framing. I don't know, maybe this drywall is just light gray and it's easier to see. I'm not sure, but either way, or it makes a gap that's easy, a shadow line. I don't know. Anyway, yeah, if it's not required, I can't tell you to spend the extra money to do it. Somebody's got to pay attention to it either way, so they might as well seal their draft stuffing that's already there. Sorry, it's kind of a lame answer.
I think that's it for now. If you want to move to the last section.
Okay, sweet. Can I go? It's 1:14 now. Can I go till like 1:25? You got a little outro, and that's.
Yeah, but yeah, if you want to leave 5 minutes for questions at the end, yeah.
Okay. All right. So townhouses, the bane of our existence as far as air sealing goes, because of this and this and this, and they just can't help themselves. I'm sorry, architects, but you do all this little bumping up and down and front and back. I know you don't want it to look like one big flat building, but holy cow, does it make it hard to air seal townhouses. And typically what architects will do is just go into the UL listed assemblies and say, okay, we're going to do this one. We've got a gypsum liner panel set between clips, or sorry, C&H studs with aluminum clips, blah, 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 blah. What that looks like is this on the inside. So very rarely are you going to get somebody to seal, you know, both sides of this clip, seal the layers here, seal this channel here. It's been done. I maybe have a picture of it in here, but it's like crazy. And I don't even know if it's that successful. The other problem is, so basically, unless you seal drywall, it's not an air barrier because you haven't sealed the seams, right? This drywall right here, nothing's gonna leak through there. It's the connections that are gonna leak, right? And then where it hits the roof, where it hits the floor. Here's one in plan. Again, like the building jogs back, which they always do. I mean, I get it, but man. So if your code inspector doesn't let you seal this and this, then you can't use this shaft liner as your air barrier. You have to use the drywall here as your air barrier, which is more work. That's the only way we've seen success is you got to treat this drywall and this unit as, you know, your air barrier. Every single penetration and connection, whatever, it's got to be sealed perfect. In theory, is it any different than sealing between multifamily units? No, but for whatever reason, just the way townhouses get built, we just see a lot more struggles with townhouses than with multifamily. I'm not entirely sure why. Here we go. Here's the section. Again, we just got to step down that hill, right? Yeah, so this air barrier here and this air barrier here is really all you got to rely on. And of course, that's going to have framing going through it. It's going to have pipes going through it. You know, it's going to have all kinds of stuff going through that drywall. Stair treads, tubs that are interrupting the drywall. Okay, here's up at the top. Again, building stepping down the hill. And now this shaft liner's got to go to the underside of the roof. This is all well and good, but like if your code inspector is not allowing you to seal this stuff, you're not using the shaft liner. Again, you've got to seal here and here. But oh wait, what about here? Good luck with that. We'll usually win an argument that just let us do, like, say, mineral wool with fire stopping on top of it. You can usually make that fly, but I mean that's a huge thermal bypass. Air is going to be constantly coming from warm and wet in here, cold and dry up here. There's an epic driving force from conditioned space up into that unconditioned attic. So here's another demising wall here. You got blocking between your floor trusses, right? Now you can't even get to that shaft liner. Oh yeah, here you go. Here they taped over the seams in the H channel. These guys were magically allowed to foam where the demising walls hit the exterior wall. I've actually never seen that allowed on any of my projects. This is one down in Maryland, I believe. There are other ways around it. You can add extra layers and, you know, do all this rigmarole and sealing and stuff. Okay, I'm beating a dead horse. Here's other townhouses. Where are the green strips? Where's the shaft liner? Well, these architects decided that there's more than one way to build a 2-hour wall. And they have 2 layers of 5/8 type X on both sides of your average wall, and they build that wall and rock it and seal it before anything else happens, before any of this floor comes in, before this roof comes in, before this floor comes in. They've got these walls built, and there you go. There's the mud on the seams. There's the foam where it hits the roof sheathing. Here's where it runs up. See, look, that probably got framed through, and they sawed it out so that they could run the drywall. Oh, no, wait, that would have been built after the drywall went up. Either way, this drywall does not get touched. For that 2-hour rating, you cannot touch this drywall. Oops, they hadn't sealed up there yet. Look at that. But anyway, it should look like this. No pipes go through it. The only thing that goes in there is electrical boxes, I believe. And those are relatively easy to seal. So as far as I'm concerned, the only way to not give yourself gray hair when building townhouses that are being held to a tight compartmentalization rate is to build like this. The shaft liner, you're swimming upstream. So, okay. Actually, I'll bust through real quick. How do we evaluate? So again, pre-drywall stage, we're doing visual inspection. Final, we're doing blower door. When I walk into an apartment, I look at every single square inch of the apartment and think, what's going to happen with the air? What's going to happen with the air? What's going to happen with the air? Look, they foamed underneath that tub. That's the best way to do it, by the way, that exterior wall. We've got checklists. Here's the manometer, which is the brains of the blower door. Oh, here's a good diagram about, so this is how we have to test. And this would be guarded testing. So these blower door fans would negate the pressure on there. We cannot do that, It works for energy, but it does not work for any of these other reasons that we air seal. Look at that, you just gotta bump those townhouses in and out. Can't help it. If you use an IR camera on new construction, it's too late, you screwed up. Okay, I'm not gonna go through all the greatest hits and fails because it'll drive everybody crazy. In summary, understand why, how, and where, know what you're being held to, detail and specify it, inspect it and test it, communicate, and you'll be just fine. And then there's a link to our air sealing guide.
Couple questions here, Steve, and
Yep.
thanks. Yeah. Is that?
That was fast.
Okay.
Sorry.
Yep. So given the critique of townhouses, what keeping aesthetics in mind, what is the best way to design townhouses with air sealing in mind, as well as aesthetics?
I knew I was going to take somebody out for that comment. I should have let off that one. That's your job as an architect. I'm an architect. I've decided that I care more about things other than how it looks. I think, if you don't mind me editorializing a little bit, yes, we can't all just live in dumb plain boxes, but I think our industry has just been so slow to react to where we're at, just environmentally. If you remotely believe the science, I'm sorry, but there's a lot more important things than just, making it look pretty from the street. I say plant some trees in front of the building. Number one way to make a building look good. So anyway, next question. Sorry.
If the space between floors belongs to the unit below anyway, why bother sealing light fixtures?
I'm sorry, you wouldn't. Let's see, if our air barrier was, sorry, let's see. Right, if this is all one volume of air, then I don't care about electrical boxes. More importantly, I don't care about sprinkler heads because you can't seal those. But if this is our air barrier and we don't want this in, then you do have to seal the electrical boxes, and you just got to live with any leakage through sprinklers. Does that make sense? Aim for the stars, land on the moon.
Can you speak a little bit to the 2021 IECC code with updated air barrier testing requirement for larger multifamily projects?
No. I can look it up real quick. Off the top of my head, here, I had it open a minute ago. Oops. Shoot, I'm sorry, I'm not on my VPN. Let's see. So for R2 multifamily, you have to do compartmentalization testing. Yeah, I just gotta stop there. I don't know off the top of my head, I'm sorry.
Yeah, if other folks have questions, I think we've addressed all of them right now. And thanks again to the sponsors of Mass Save for putting on today's session. Steve, thanks so
for
much.
having me.
Appreciate your expertise.
You bet. Take care.
Okay, take care. Bye.